All right, let's take a look at this related rates problem. We are given that an area of a circle is increasing at a certain rate. I'm labeling, obviously, the circle's radius R, the area of the circle is A. And part A, they ask you to find how fast the radius of the circle is changing when the radius is a certain quantity. So in this particular problem, the given rate of change for the area of the circle is 5 square centimeters per second. Again, your problem could vary depending on the situation. And then find dRdt when, in this problem, it was when R is 6 centimeters. So these numbers here could vary, but the problem is basically set the same way. The equation that relates the variables of interest, the area of a circle, right? Area is pi r squared. Take the derivative with respect to time. So dA dt is what? Pi is a constant multiple pulled out. Derivative r squared is by the chain rule. Remember, r is a function of time. R is not constant. So this will be derivative of the outer function 2r, or 2 pi r, times the derivative of the inner function dr dt. So here's our related rates equation. Now we can plug in information. dA dt was 5 centimeters, square centimeters per second. The radius now is 6 centimeters, so I replace that there. Of course, this becomes 2 times pi times 6 is 12 pi. Divide 5 by 12 pi, that will give me dr dt. Notice the units of dr dt are centimeters per second. Now, part B is a little wrinkle. It says to find dr dt when the circumference is a certain quantity. In this case, it's when the circumference here is 6 centimeters. Again, your problem could be a little different. So how do we do this problem? Well, all we need to do is, what is the radius when the circumference is 6 centimeters? Well, you need to know that the circumference of any circle is pi times the diameter, or pi times twice the radius, or 2 pi r. So I can uh, plug in that the circumference is 6 centimeters, and then I can solve for r, right, but by dividing by 2 pi. So the radius must be 6 divided by 2 pi, and 6 divided by 2 in this case is just 3. So I get 3 divided by pi. So now it's just like part A, where the radius is 3 divided by pi centimeters, okay, which is just slightly less than 1 centimeter. Okay, so we're going to now just plug into the same related rates equation. Again, dA dt is going to be 5, but this time r will be 3 divided by pi. When I multiply 2 pi times 3 divided by pi, the pi's cancel. I just get 2 times 3 is 6. And so solving for dr dt means divide by 6. So dr dt is 5/6 centimeters per second. Okay, hope this one helps.